Okay, this is geometry 4.5, still talking about transformations, although in this case, dilations. So a dilation is a transformation that either reduces or enlarges an object about some fixed point, call that C, or that fixed point is also referred to as the center of dilation, using some scale factor called K. So a transformation that either enlarges or reduces an object about some fixed point. Call it C. Again, that's the center of dilation. Kind of like you had a center of rotation using a scale factor K. Okay. So if I wanted to dilate a specific object, such as a point, could be a segment, could be a polygon, I need a center of dilation, and then I need some scale factor, K. Okay, so in this case, I want to dilate my point P. I'm just going to take it step by step. Instead of trying to dilate an entire polygon first, I'm just going to dilate a single point, specifically about the center of dilation, point C, and the scale factor is 2. So K is equal to 2. Think for a minute, maybe pause the video, whether this would be an example of a reduction or an enlargement, and then explain your reasoning. So if you figured out this is going to be an example of an enlargement because K is equal to 2, that would be correct. Okay, if K were equal to 1/2, 1/3, something like that, then it would be a reduction. Okay, anytime K is greater than 1, that would be an enlargement. Some people say, well, if K is a fraction or if the scale factor is a fraction, then it's an enlargement. Not quite, because a fraction could still be larger than 1. Like if the scale factor were 7/5, then that would still be an enlargement. That's a fraction. If the scale factor were 5/7 or 5/7, then yes, that would be a reduction. Okay, but here's what you need to do to dilate the point. Okay, since the scale factor is 2, you got to plan ahead. Okay, I need to make a ray similar to what I did with a rotation. The ray is going to have the center of, in this case, dilation as an endpoint, and I should make it at least twice as long as from C to P. Because the scale factor is 2, that means point P would be twice as far from point C, the center of dilation. So exaggerate if necessary. That's definitely twice as long as CP. And then I could either use my compass, like I did before. Again, if I'm using my compass, I don't even need to know any measurements as far as in inches or centimeters or anything like that. Here's the distance from C to P. If you can see that right there. If we were in class, like this is a sharp point, or I sometimes refer to it as a stabby point of the compass and then the writing part. But this length right here, since this is fixed, if I don't close it or open it up any, then this is the length of CP from this point to this point. So then I want twice that length. Here's 1 times the length. Then now put the end point of my compass or the stabby point on point P, and then mark, this would be an arc, just part of a circle. Because I can rotate this 360 degrees as long as this stabby part or the sharp part stays at point P, and then make a circle. But these 2 segments are congruent. This would be P prime, because CP prime, that segment length, is twice the length of segment CP. If the scale factor were 3, then I just repeat the process again. And let's just say I change the scale factor to 3. I still have my original pre-image point P, original center dilation, and then P double prime would be right here. Okay, the length of CP double prime would be 3 times the length of CP. Okay, and then I could repeat the process if the scale factor were 4 or whatnot. Okay, if the scale factor was something like 3.5, it gets a little bit more complex. Maybe then you're using a ruler or possibly using sticky note, marking off the distance. Here's the distance from C to P, twice the distance in C to P, 3 times the distance, and then just take half of that. If you could see this marking on my sticky note right here, from this endpoint to this endpoint, okay, without having to take any measurements, I could just fold it from endpoint to endpoint. You can see what I'm doing. and then make a crease. This is half the length of CP. So if I change it to scale factor of 3.5, then it'll be something like this. P triple prime, that's a scale factor of 3.5.